Today, artificial intelligence is everywhere. And if you're working in IT or you're a developer, you've probably either already come into contact with AI, or you may very soon find yourself to be involved in some projects with AI. And I think it's very important that we take a minute and understand that AI is a launching off of the human brain. And so if we take a moment to think about where we've come from with AI and look at the architecture and the plan of the human brain, it's going to give us some hints about how we need to evolve our IT architecture to be more AI ready across our technology. And so, here's a really little cartoon summary. So when we think about AI today, we have the internet, and the internet's got tons and tons of data. And so really where the current GPT-driven large language models and the sort of new paradigm of AI that we're in today has real heavy overlap with the internet, because basically, the GPT models kind of swallow the internet and process it, and then create these large models that have a really good understanding of text and images and these new applications. Okay, so this first paradigm is sort of AI swallows the internet, right? And so when we think about this framing, this is not real useful for us inside an organization. When we're inside an organization, we care a lot about specific things that are applicable to our organization. So, the data that we care about inside an organization is very different than all the data that's in the internet. And when we think about our organization, we have important, applications, and maybe some of that is SaaS, and maybe some of that are things that we've developed internally. But we've got kind of this executive functioning layer of our applications, and then of course we have networking that kind of connects everything together. But the challenge that we have with this sort of existing IT infrastructure and AI is that now we're in a paradigm today where we're in this kind of like plus AI paradigm. So it's kind of like, this is what we've got. We've got data and apps and SaaS and networking, and we're in this sort of like, now we're trying to have sort of AI swallow the enterprise, right? So AI swallowed the internet, and now we're trying to kind of jam AI into the existing enterprise. And the problem with this, okay, with this is that we're seeing 90% plus failure of AI initiatives that are happening in this style, okay? And so what we really probably need to get to is a world where we need to get to a world where our AI, okay, is a plus, but we need to get to a world where we've got a little bit more organization and separation of kind of what our data sources are, and what our tools and executive capabilities are, and then how that's going to interact with AI. And of course, the goal here is to kind of reverse what's happening down here, and let's try to get to 80% plus success rates in our AI initiatives. So we've talked a little bit about where we came from and kind of where we're at. And let's take a step back now, and let's talk about, what are we trying to mimic? When we're talking about artificial intelligence, what we're really trying to do is we're trying to mimic human intelligence. And so all animals, okay, all biological animals have a body plan. And a body plan is kind of a biologist's way of saying an architecture, right? An IT person would say an architecture, biologist says body plan. So here we have a brain, and we have, this main region in the top where most of the action is, right? Which is the cerebrum. And then we've got this sort of midbrain area, and we've got a little thing back here called the cerebellum, which is Latin for small brain. And then you've got this nerve cord, right? So this is your nerve cord, and it runs down your backbone, right? So vertebrates have their nerve cord running down a backbone, and invertebrates have their nerve cord not running down a backbone. But what we're basically, this body plan is basically designed to sort of process data, right? So we're processing data from the environment, and we're sort of generating responses. Okay, so we're getting data here, from all of when our body touches things and feels things. We're getting data coming in here through our ear. We're getting data coming in here through our olfactory area with the nose and the mouth. And the reality is that your eye is a little bit down from here, but basically you're getting in data here from smelling and tasting. You're getting data from hearing, which is auditory. You've got a big data center coming in from optical data when you're looking at things. And so you've got all this data coming in, and the brain is basically organized into three parts, sort of three regions. You've got the lower brain, you've got the midbrain, and then you've got this upper brain area, right? And so in the lower brain, what you're doing is you're processing really primitive data and really primitive responses, right? So in the lower and a little bit into this midbrain area, we're monitoring the temperature. We know if we're hot and cold. We know if we're being if something is hitting us or punching us or biting us. As we move up into the midbrain, so the lower brain is like really primitive. The midbrain starts to be about connectivity. So the midbrain is handling a lot of data exchange, what gets ignored, what gets stored in memory, what gets moved around to different parts of the brain. And if you look at this picture from the top, most people know that there's a left and a right hemisphere to the brain. So we're like bilaterally symmetrical. You've got this left and right brain. And right here in the midbrain as well, you've got this very important structure that connects and allows for communication across those two hemispheres. So really, midbrain is about connectivity. Lower brain is kind of primitive functioning. And then if you look at this, look at all of this real estate that we have. We got a huge amount of real estate left over up here. And if you go and look at the literature, this really big region up here in the upper brain is oftentimes described as being in like 4 parts. So there's kind of like 4 parts of this thing. And this frontal part, the frontal area, is where we're really getting our executive functioning. Okay, so this is really the pilot. So when you get up and whatever you're deciding to do next right now, if you decide to pause this video, it's this frontal brain area that's integrating everything that you're experiencing and kind of deciding what to do next, right? We've got these sensorial areas, okay, that deal with processing auditory data that's coming in through our ears. We've got a big optical area towards the back of the upper part of the brain, and we've got these upper regions that allow us to integrate and do really long-term strategic thinking. So one of the great things a brain does is really, the $1 million thing that the brain does that we can't. That we have a hard time figuring out how to replicate is the brain is like really amazing at integration, right? So it's really good at integrating. So when you're asked about a memory of like, hey, you were at the beach last summer, when you think about that moment, you may be remembering salt smells, you may be remembering the sound of the waves, you might remember the taste of some really great crab cakes that you had while you were there, and you may even remember stepping on a sharp shell, and cutting your foot and experiencing pain and having to go get stitches. But the thing that's amazing about the brain, right, is this ability to integrate and kind of know when to take bits of all these different senses and all of this different data. Now, the last thing I'll say about the brain that I think is foretelling about when we think about artificial intelligence in the enterprise is the brain ignores almost everything that it experiences. So what's amazing is that we completely ignore about 99.8% of all the data that we come into contact with. And so if you think about your drive to work this morning, Okay, you're not, you know that there were other cars on the road, but your brain knows to ignore the sequence of colors of different cars or the make and models of different cars. Now, if a Ferrari went zooming past you, you might remember that because it's kind of really out of the ordinary. But the brain is incredibly good at ignoring like almost everything that you're coming into contact with. And it's very good at storing things that really stand out that are likely to be important in the future. Okay. So now let's talk a minute about where we're at with our enterprise sort of IT architecture. We're going to keep this super simple. So we're going to keep this in 3 categories. Okay, we're going to talk about applications. Okay, so applications, are things that do things, right? So it's kind of like executive functioning applications. 2 is data. So all different types of data that we're storing, and 3 will be network. Okay, so network again is kind of how we connect things. It's our communication plan. Okay, so when we sort of start looking at our applications, let's put just a couple of these over here. Maybe we have like a CRM type of a system. Maybe we have a human resources information system. Maybe we have a sort of financial accounting type of system here. And, maybe we've got, something that's sort of a legal system that holds contracts or other kinds of documents that might be of a legal nature. So here are our applications. And then typically, we're going to have some type of data layer. Okay, and so I'm going to write the word data lake right here. And don't be offended by data lakes. I know that some data lakes are constructed to where we feel like everything's just kind of dumping into them. And other data lakes have been carefully constructed so that you've got some really nice logical layers and they're really useful, right? But whether your data lake is a swamp or whether it's really useful, the idea is that we've got these applications. The applications themselves have data and have users and have executive functioning. And we typically connect them and sort of dump data into something that might look like a data lake. Now, in the past, when we're trying to do things across these applications, we end up in sort of a bad, what I would call like kind of a star structure, right? So I've got my CRM, my HR, my financial, my CLM, and this may have been, this is something else. But what we typically do is we use an API type of paradigm. So we use kind of an API paradigm here, and we say, well, the HR system, needs to go grab some information from that system, and the CLM system needs to push something to the financial system, and the financial system also needs to talk to this other system over here. And so we kind of end up in this connected world where we're relying heavily on APIs, and we're relying really heavily on very structured types of integrations that do very, very specific things. So when we're building this type of architecture, we really can't leave much to chance. If we leave much to chance over here, things start to break. Okay? So the big question is, how do we move from this paradigm where we've got kind of AI kind of being jammed into the picture into a paradigm where this type of a picture becomes more AI ready? Okay, and so let's take a shot at that. The first thing that we're going to need to do is we're going to need to scotch this API as the dominant interface, because we're going to need to introduce a new character into our story. We're going to need 2 new characters. We're going to need a new orchestration layer, and the orchestration layer is going to spawn armies of AI agents. So we're going to have lots of different AI agents that are going to be able to be spawned out of this orchestration layer. Now, what good is the orchestration layer right now if it's not interconnected to the rest of this world? And what good is it if we're kind of up in this type of a world where everything is kind of already connected in very specific ways? Well, without interrupting how we're operating today, we can start to do some new things, which is to make sure that each of these applications gets an MCP service. So MCP service stands for Model Context Protocol. And I'll just put an M here. So for each of these applications that we're using, and for the different areas in our data lake, maybe we partition our data lake a little bit and chop it up and organize it so that these things can start to become MCP. We can have MCP hosts that are providing MPC service to our agents, okay? And so when we add orchestration and when we transform our applications into now being able to be MCP services, what that's doing is it's exposing these applications as basically sets of tools. Tools is like, what can I do? And data sources, which is like, what do I know? So tools are what can I do? Data sources is what do I know about? Okay, and when we start to look at having MCP services kind of distributed here and where we can communicate and ask and go ask agents to go do specific actions across this infrastructure, we're kind of eking in the direction of looking more like this picture. Okay, because the ability to orchestrate, you can almost look at, these different applications kind of as different organs in the brain. So maybe the CRM is kind of like my ears and my auditory center. My HRIS system might be kind of like my olfactory, nose and mouth. My financial and accounting system, might start to look more like my upper kind of strategic part of my brain. My CLM system, might be back here in the rear as part of motor coordination or something. But ultimately, we start to have sort of organs which remain specialized, but by putting in the MCP and expressing themselves as tools and data, and by breaking into this data lake and creating, what we call an AI-ready data layer, okay? When we get to an AI-ready data layer instead of a data lake, and when we get these executive functioning applications able to interact with MCP, then we can send lots of agents out, and these agents almost start to be like synapses. Synapses are the structure that connect neurons in the brain. And so what the brain is able to do is when you want to do something super complicated, your forebrain, this executive functioning frontal area in here, I'm going to try to use a different color. So when you go to do something complicated, you're activating this integration in this executive functioning here in this forebrain. Well, what's going to happen is that's going to be this orchestration layer over here. So when we want to do something complicated, we're going to want to activate this orchestration, and then what we're going to do is we're going to know, are we calling on hearing? Are we calling on our olfactory senses? Are we calling on some really higher level strategic functioning? Is the task needing to call on motor coordination? And we can start to develop a very strategic approach to doing very complicated things. Now over here, that's what this architecture starts to look like, because you've got sort of your orchestration is kind of your frontal lobe. It can basically look at, in the agent framework, it can basically say, look, let's talk about goals we're trying to achieve, and then outcomes that are going to be acceptable. Okay, and so goals and outcomes start to kind of be more the way we work in the human brain. We can use the orchestration layer, and we can light up, all these agents, kind of like synapses, to go out across all these different functional, executive functioning parts of the application layer, and that they can also, the agents can also, let's go back to our agent color, the agents can also come down and jump into areas of the data layer as well. And so the goal of this conversation, was to kind of use a little bit of a cartoon and have some fun, but it is to remind everybody that artificial intelligence is literally trying to replicate the kind of incredibly integrated functioning that we have in the human brain with biologic intelligence. And so if we take a look at the human brain and we look at how integrated it is, we look at how compartmentalized it is, we look at how organized it is, we look at its compact nature, we look at the fact that it runs on very low power, and then we can start to see sort of where we maybe want to go with the enterprise IT, so that we can be more AI ready across the enterprise.